everyone, it's Madison again. I wanted to introduce our next speaker, Sammie Jiang. Sammie loves to help people fall in love as a senior backend engineer at Coffee Meets Bagel. It's not a cafe. She did also previously did a short stint in cybersecurity, first in network security, and then continuing to a new product for security/monitoring in the IoT/OT sector, which is where she first started her Python journey. Offline, she loves dancing, shredding POW, and vegan pastries. Please give a warm welcome to Sammie for her talk, Climbing Out of Fixture Hell Indirectly.
Thanks, Madison. Okay. Good morning. I'm Sammie. I'm really honored to be here. It's my first time at PyCascades. I'm really excited for all the talks today. I think it's really cool to hear people talk about things that they're interested in and that they're working on. So yeah, today I'm going to be talking about testing, specifically how we write tests using PyTest, and how we can make them simpler and easier to work with as your code base grows using indirect parametrization. And the goal isn't just to introduce a feature, but to help us build a better mental model for structuring tests, so that adding new cases doesn't just keep increasing complexity over time. So a little bit about me. I'm Sammie. She, her pronouns. I'm a senior backend engineer at Coffee Meets Bagel, which is a dating app if you haven't heard of it before. And it's always cool. Every time I tell someone, I feel like I always hear about people saying that they met their partners on the app. So it's a cool motivator to go to work every day. And this is my boy, Ross. We named him Ross after Ross from Friends because he was a really mopey boy as a puppy, and he has a really long face. Yeah, so let's get right into it. So the tests that we wish we had, we wish all our tests were this simple. We're testing an admin can access a dashboard. We just get the result from can access dashboard, and then we assert that the result is true. But oftentimes, it's never that simple. On tests that we actually ship and write, we have to set up the admin user that we need. We gotta log in the user, set up our dashboard, do all these things, and then the actual test is just the last 2 lines. And we can improve this a little bit by elevating some of the setup into fixtures. So we could use an admin user fixture or a dashboard fixture. And if we do this, where would the fixtures live? So sometimes we put them at the top of a test file, and other times we put them in our conftest.py. So in our conftest.py, we might have a user fixture. And in the last one, you saw that we were using an admin user, right? So we might end up with an admin user, and then we create a guest user, staff user, and so on. And then you might find that you need some other types of users. So then we end up with a verified admin user, a premium admin user. And very quickly, you end up with some monstrosity, like a verified premium logged in admin user. So now we've ended up with many different fixtures just to create slightly different versions of the same thing. So the issue here is that our fixtures are modeling a named combination of states. Logged in is a state, admin is a state. And this scales terribly with every new access. Every time you have a new subscription, you need another version. Every time you have a new platform, any other state, you're going to end up with several different combinations of these fixtures. Instead of having these states as parameters that we could pass in values to. So logged in is a state that we could pass in a Boolean true false to, and then role could be a state that we pass in a simple string like admin or staff. So if we take a step back for just a second, if we didn't have fixtures, how would we test different combinations of states? At the very basic level, we could use direct parametrization, where we pass in a simple value to a parameter called role, and we can pass in a string like admin. And that gets directly passed into the test, and then we set up a user with that role. But then the test is still doing the setup every time. So You might have another test that needs a user, and then you have to set up the user again. And so you're writing a lot of repetitive code. So how can we get a user that is already set up, but then request it to have an admin role? Say we wanted a user fixture. So we want something like this, where we could have the test pass a parameter to a fixture, and then the fixture does the setting up or the building of the object, and then returns that back to the test. And so we can do this with indirect equals true parametrization. So I'm going to get into some just basic syntax around indirect equals true. In this case, where we're testing the user, admin is the value that we're passing in, and then user is what we're passing it to. And because we have indirect equals true here, we indicate that we're passing it to a fixture. So if we look at the fixture for user, there's a built-in PyTest fixture called request that we can use. And we can access the parameter value that we pass in using the request.param attribute. So then user effectively would get admin passed in through request.param. And then you just have to make sure that the name of the parameter matches the name of the fixture exactly in order for PyTest to know where to pass it to. And you could also have multiple params. So if you want an admin user or a guest user, you can list multiple parameters. And this ends up with 2 individual runs of the test, 1 run per value. And you can also set up defaults for your fixture for cases where you might not want to pass a parameter in. And in that case, then it would just use the default parameter. And then test IDs come free because you're passing in a simple identifier, then in your test it's really clear exactly what you're testing. So now we've kind of achieved what we wanted, right? The test passes the role to the user fixture, and then the user fixture builds that user with the role that we want and then returns it to the test. So effectively, we've passed a parameter role indirectly into the test instead of directly into the test, which is exactly where the indirect name comes from. Okay, so let's circle back a little bit to how this applies to that somewhat problematic test that we started off with. So we had that test example from the beginning where we're testing an admin can access dashboard. We set up an admin user, we set up a dashboard, and then the actual test is just the last line over there. And you've probably seen tests like this. I know I've written tests like this. And your tests are actually doing work that they shouldn't have to. Your test should describe what they need, not how to build it. So the what here is it needs an admin user and a dashboard. And the how is that it's setting up the admin user and then setting up the dashboard. So how do we rewrite this so that it can fit our mental model, where the test should just describe what they need, not how to build it? So let's elevate some of that setup into our fixtures, right? We have an admin user fixture, a dashboard fixture, and then now the test describes only what it needs. And now it becomes very clear exactly what the test is validating as well. But if we move the logic into the fixture, where does it go, right? It ends up in that conftest.py dump, where we end up with all these combinations of fixtures, and we end up with like a fixture explosion. So, when we end up with like 4 different combinations of the fixtures, you also end up writing 4 different tests to test each of the combinations. So our fixtures end up being 90% copy and paste, and then our tests are also duplicated. You have the same assertion logic, just with a different test fixture name. And so we can solve this with indirect parametrization. Because we can now pass parameters into a fixture, we can now consolidate all of these fixtures into one user fixture. And with indirect parameterization, you only need one fixture per data type. And so effectively, in this example, you only need to write one test as well. It's just the test user, and then you're passing in the parameters. And so old man celebrates. So let's look at how this might look in our code. Now, instead of passing fully constructed user objects into the test, we're passing something simple, a string identifier, admin, staff, guest, and then we let the fixture handle the setup using request.param. And the test continues describing only what it needs, which is an admin user, or a staff user, or a guest user. So before, we had 3 fixtures: an admin user, a staff user, and so on. And now our new user fixture, the consolidated one, it just describes how to build what the test needs. So when we need an admin user, we're going to return a user that has read, write, and delete permissions. And when we need a staff user, it's going to return us a user that has read and write permissions, and so on. So I like to think of this as, instead of separate fixtures, you're really just passing different forms, and you're letting one fixture handle it. So basically, it's like ditto. And now the test describes what it needs, and the fixture describes how to build it. So now we've been able to pass parameters one level up into a fixture. So you might think, how many levels up can we go, or should we go? So you might have, so we start off with the test can access dashboard. Maybe you want to take in a logged in user fixture this time. And then you want to pass a parameter indirectly all the way up to the user fixture. And the logged in user depends on the user fixture. So we look at this in code. Starting from the bottom up, if we have the user fixture, and then you have a logged in user fixture that depends on the user fixture. And so all logged in does is just logs in the user. And then our test takes in the logged in user fixture and passes the parameter all the way up to user using indirect equals true. And PyTest does allow this. This works. So effectively, what we've achieved here is a logged in admin user. But now if I'm a reader and I'm just coming in and looking at this test, we see a logged in user fixture, but we're parameterizing something called a user that isn't shown anywhere in the test. So now we have to follow the chain up all of these different fixtures and up through to find request.param to see what we're actually parameterizing. So when you're parameterizing one level up, that's sometimes fine if, like, for example, logged in user is pretty clearly named and self-explanatory. You can kind of deduce that, like, user is related. But if you're going like 2 or more levels up, often it becomes a anti-pattern or a code smell. And so you end up with kind of a fixture maze where the reader has to go through this maze to figure out what's happening. So at that point, you might just want to call fixture normal fixtures or maybe helper functions. So that's something to keep in mind with indirect parameterization. It's a bit of a limitation because at the end of the day, clarity and readability is still the goal. And if fixtures feel magical, then you've already lost clarity. So yeah, it's like the impossible problem, right? Fixture explosion or fixture maze, and you kind of want to avoid both. Okay, so going off on a slight tangent, but indirect parameterization helped us simplify different test states. And another thing that kind of trips people up and kind of tripped me up for a while is scope confusion. And as a side effect, indirect parameterization can make it easier to reason about as well. So let's look at a let's say, an expensive database fixture, and it's function scoped. So it's performed every single test run. And all this does is it sets up the database connection, yields it to the test, and then when it comes back, we clear the data and disconnect. And let's say it takes 2 seconds for every run. And then we have 3 tests that use this fixture, pretty similar to before. And all it does is it sets up a user, and then you just need to take note that it tries to use the same email every time. Creates a user with a role and the same email. So now we look at how the flow looks when we run this entire test suite. Because the database is function scoped, we're going to connect and then clear and disconnect after every single test. And then each run is 2 seconds, so we have 6 seconds total of connection overhead. So you might think, okay, how can I optimize this? Let me just change it to module scoped, right? So all of a sudden we're going to have 2 seconds of overhead. And then you're going to find that your tests start failing. And the reason is because we connect and then we clear the data after the tests or the test files are done. So on the first one, we created a user with hello@pycascades.com email. And then on the second one, we're going to end up with an integrity error because that email's still in there, right? You have a unique constraint on the email. And then same with the last one. So we're stuck. We want the speed of a module scope fixture, but we don't want to wait 2 seconds every time. But we need the clean database of a function scope fixture so that the unique emails don't collide. So the mental model here is that we want to share the database connection, but be able to isolate the mutable data. And we want to be able to split them up so that the connection can be at a higher scope, but then the mutable data can be at the function scope. So how would that look like as fixtures? Let's say we have the database connection, which is still module scope, so we just do connect and disconnecting, and that's 2 seconds for all 3 tests. And then we have a mutable data fixture, which is going to create the user and clear the user after every single test. So that should allow our test to pass, but we're still using the 2-second connection. Yeah, so this is the database connection fixture from before, but all it's doing is connecting and disconnecting, and there's no clearing of the data. And then we can look at the user function scoped fixture. And because it's function scoped, it's run after every single test. We pass a role in as a parameter, and we can use a request.param trick like before. And then we create the email, the user with the email yielded to the test. And then most importantly, we flush the database afterwards to ensure that the integrity errors don't happen. And so the data is isolated. And so now look at what happens to our tests. Because the isolated fixture handles creating the specific role, injecting the emails, and then cleaning up the database, all 3 tests end up doing the same thing. So we can just consolidate them into one test because the logic is going to be identical. And then we can do that with parametrize indirect equals true. So now, if we look at the flow, we have the connect, disconnect connection that's shared, and then the data gets cleared after each one. So the total overhead is just going to be 2 seconds. Yeah, database connection only happens once, and then there's no email collision crashes because the fixture flushes the DB after each test run. So yeah, just a quick mental model. The things that we want to share are things like connections, auth tokens, clients, expensive setup. And the things that you want to isolate are cache entries or test-specific state, mutable data, anything that tests are going to modify. So to finalize with some best practices, we want to maintain test clarity. Ensure that the use of indirect parametrization makes your tests more readable, not less. And if you have highly complex setup where the simple indirect parametrization might be awkward, consider using factory fixtures. Try to use lazy fixture setup. So set conditionals in the fixture to use less expensive resources if the test doesn't need it, or set the default param as the cheap case or the most often used case. And avoid a God fixture. Now that you're passing parameters in, it's also possible that you end up with some gigantic fixture that tries to do too much with a whole bunch of if-else conditionals, and that becomes its own problem. Yeah, thank you. That's everything I have.